So we have a quick video today on edge effect. What is it? What is pass pointing? And when would you use a wedge pair when you are planning? So the edge effect also is called tissue lateral damage, depending on who you talk to. And it ultimately what this shows and what this does is when you use parallel opposed fields, treating one field each day gives actual greater biological damage even with the same overall dose. So that's what we talk about when we say edge effect. And somewhat similarly, when another treatment technique is called pass pointing. And so this is when you're using partial arcs. It doesn't account for full arcs, but with partial arcs, the point of focus, which in most case is going to be the prescription point. So say if we have a head and our RX point, prescription point is there in the middle. If you have just a partial arc, say coming like this way, because you want to avoid the eyes, right? You don't want entrance or exit dose through the eyes. So with these partial arcs, you could put the point of focus actually past the prescription point where you actually want the dose. So if you put your prescription or your focus right here, that is going to help you get maximum dose where you actually want it, pretty much max dose to the tumor site. Because if you would put focus right on the tumor, then ultimately it's going to be a bit underdosed actually. And this entire pass pointing technique should be determined on a per patient basis. It's not like every time you use pass pointing, you need to use, or anytime you use partial arcs, you have to use pass pointing. It's on a per patient basis. Sometimes it's helpful, sometimes it doesn't really make a difference. And then finally, when would you use a wedge pair when planning? So it's important to know that we'll see how my drawing is here, that when you use a wedge pair, one, it would look similar to this, where you would have the two 90-degree angles close to each other. And when you use this, it's going to give you a very favorable dose distribution. Something that if I'm drawing the 100% ISO line now, it's going to look kind of like of course, this isn't to scale and it's a rough drawing, but this you get this diamond shape. And the idea is that the tumor is normally 0 to 7 cm deep. So it's not super embedded into the body. It typically the tumors are going to be small. And because it's 0 to 7 cm, normally the tumor is also going to be somewhat superficial to the body. But this dose distribution that you get is very uniform. It's cooler than most plans, and there is a higher, faster dose fall off when you use wedge pair compared to just maybe normal parallel opposed fields. So know when to use a wedge pair, what the advantages are, because that's a question they very well could ask, and one you should certainly know. If you have any questions, please comment below. Thanks for watching and happy studying.